Hello and howdy, ladies and gentlemen. Root Beer here, and I'm going to be going through another University of Waterloo math contest. This time it's going to be the Galois paper from the year 2012. You can get a copy of this contest for yourself by clicking the very first link down in the video description. Here's what you'll see. Here's my copy of the Galois. It is the 2012 paper, as I said. We can see it is the grade 10 level contest. Now, Waterloo puts out two grade 10 contests. This is the written one, where we will have to write out full solutions for some of the questions. The other one is the Cayley paper, and that is just multiple choice. Okay? So, usually, at the start of these videos, before I dive into the very first question, I try and encourage you guys to get a copy of the contest for yourself so you can try it out. If you are going to do that, give yourself 75 minutes or an hour and 15 minutes and give it a good try. There are only 4 questions there, but practice makes perfect. One of the things that can make you really good at math contests is practicing a whole bunch of them over and over again. A lot of concepts come up a whole lot. Pythagorean triples, 3, 4, 5 triangles, circle geometry, certain types of sequences like arithmetic and geometric sequences, certain formulas. Lots of things can come up, and if you read solutions or watch my solutions and try the questions out for yourself, you will see these things. You'll see the things that you're good at, and you'll see the things that you're not so good at and you need to focus on. And by watching videos like mine, you might be able to develop or pick up a new technique. And if you ever learn something that, or know a way to do a question that I don't go through or that I don't do, by all means, let me know down in the comments below, because I like learning how to do contest questions even better too. Alright, so as I said, there's 4 questions. We're just going to go through question number 1 in this video, and then question 2 in the next, and so on and so forth. So here we go. Question number 1 is about Adam and Boudin. They're playing a game of bocce. Each wants their ball to land closest to the jack ball. The positions of Adam's ball, A, Boudin's ball, B, and the jack ball, J, are shown in the diagram here. And then we've got some questions for question number 1. So we've got 2 of these light bulb questions. These just mean put your final answer. Show work if you want to, but all we really care is, do you get the right answer? If you get the right answer, you'll get full marks. If you didn't get the right answer, we will take a look at anything you have written, maybe give you part marks. And then the last bit, C, has this hand with pen to paper. We're going to have to write full solutions, justify what we're talking about, use full sentences, show our calculation, that sort of stuff. Alright, so A part, what is the distance from A to J? So A is over here, J is here, and actually let's get those markings out of the way, because one thing I can notice is there's a lot of right angle triangles here. So I'm thinking the Pythagorean theorem is going to help us out a fair bit. Now, A to J, well, the AJP is a right angle triangle, and I know 2 of these sides, so this shouldn't be too bad to work out. In fact, I'm going to copy this picture down. So there's a 39 here. I think this was a 15. And this one was definitely a 15 and a 20. A here, J here, and it was P. I'm going to guess this was Q, and this is B. I'll just double check that I got it right. Yep, 15A. Yep. Everything's good. Okay, so if I were going to write something down, and again, it's a light bulb. I don't have to. I could just get the final answer, which I can see is going to be 25. But that's because I've done a lot of math contests, and I know 15, 20, and 25 are what we call a Pythagorean triple. They're a set of integers that can be placed around a triangle that has a right angle in it. Okay? So, but if I didn't do that, I'll show you the work I'm going to do. So here's, if I didn't know that, I'll show you the work I'm going to do. So, triangle JAP is right angled. And you can say by Pythagoras or by the Pythagorean theorem or whatever you want to do. You can say that AP squared plus PJ squared is equal to AJ squared. And AJ, that distance, is what we want. So 20 squared plus 15 squared. And you're allowed to use your calculator on this contest. I should have mentioned that a little earlier. So you can absolutely grab your calculator. Or maybe you've seen these numbers enough that you don't need to grab your calculator. I've got my calculator handy, but I always try and avoid using it if I can. I like making my brain work a bit. And 625, well, you can press the square root button, or you can just say, well, that's 25 squared. So AJ is going to be 25. Or, because it's a light bulb question, if you recognize the Pythagorean triple, just put 25 and you're done. So that gets our answer for A. B, what is the distance from B to A? So that's this distance over here. So I can see it's part of another right-angled triangle. Okay. So we could, again, say something like triangle BQA is right. So by the Pythagorean theorem, or by Pythagoras, whatever you want to say, and you don't have to say it again. We know that BQ squared is QA squared plus AB squared. So this is 39 squared, this is 15 squared, and this is AB, which is what we're trying to figure out. 39 squared, I actually don't know that one off the top of my head. I think it's 1581, but I'll grab my calculator and double check. 1521, I was close. But it's a good thing we had the calculator to double check. And once again, we got a 225 here. Well, let's bring the 225 over to both sides, or over onto the left-hand side. And we'll get 1296 when we subtract there. Okay, and then, well, we square root. You can grab your calculator if you need to. But I recognize this as 36 squared, so AB is 36. Now, of course, again, if you know your Pythagorean triples, you might have 15, 36, 39 memorized, or you might say, oh, 15 is 3 times 5. 39 is 3 times 13. And a very popular right-angle triangle is the 5, 12, 13 triangle. So this has just been scaled up. So the missing side should be 3 times 12, which is what 36 is. Okay? But there we go. We got our answer, 36. That's the distance from Adams to Boudin's ball. And now C part. Determine whose ball is closer to the jack ball, Adams or Boudin's. Okay. So, for C, we want to know which is larger. Actually, we want to know who's closer, so we want to know which is smaller. AJ, which we already learned was 25. Or BJ, from Boudin's ball to the jack ball. Now, we don't know this yet, but we can work it out. So the jack ball was here, the right angle. A is here, B is here. We know this is 36, and I would say by part B. We know this is 25 by part A. Okay, so now we can just sort of work it out. So by Pythagoras, BJ squared plus AJ squared, we'll just say by Pythagoras up here. BJ squared plus AJ squared is 36 squared, so the thing we're missing is BJ. So BJ squared is 1296 minus 625 when all is said and done. And we can work that out. I'm just going to grab my calculator here. 1296 minus 625. And I get 671, which sadly is not a perfect square. So BJ is the square root of 671. And you could say, well, I'll grab my calculator, and square root of 671 is a little more than 26. Oh, sorry, a little less than 26. 25.9 something or other. And that's fine. You could say that, you could write that it's approximately 25.9 something. And that's perfectly acceptable. They know you're allowed to have a calculator. But of course, you could also say, well, I claim that BJ is bigger than AJ. And here's how I would show it. So I could say something like BJ squared is 671, which I know is bigger than 625, which is 25 squared, which is AJ squared, so square rooting both sides. BJ is greater than AJ without actually having to approximate it with decimals. Okay. So, Adam's ball. It was Adam. Adam's ball is closer, so I believe he wins bocce ball, the game of bocce ball. Is it just called bocce, or is it bocce ball? Just game of bocce. Okay. Whose ball is closer to the back? The jack ball. Adam's ball is closer. That's all you need to say. Okay. And there we go. So that's question number 1. Up next, we're going to take a look at question number 2 on our Galois paper, and then to 3, and then to 4. Feel free to bounce around. If question 4 is calling your name, I will see you in that video. But until then, have a wonderful day, and thank you so much for watching.